Hey guys, I am back again. I think we can start. Yeah, maybe more people will join in a while, but we can start and let's see. I really hope you can hear me, to be honest, because right now I am on vacations. I'm in Greece. I'm not in Munich. It's around 36 degrees here, so it's quite hot, I would say. And I was testing the network here. Seems everything is okay. I really hope you can hear me. Please say something if you can just see my mouth moving and don't hear anything.
Yeah, I hear you. Hello, George.
Anyway, today we just before we start our meetup. This is quite common, but I have to say it every time. We are recording this meetup, this talk, this session, and we plan to upload it to YouTube. So if anyone has any objections about it, please feel free, contact me, and we will blur you out or your image, your sound, whatever you want. That will not be a problem. Now, today we have a very interesting talk by Kamil Grzybek. I really hope, Kamil, I'm saying that correctly.
Yeah, it's correct.
About modular monolith architecture. It's kind of a very interesting topic that I was waiting for a long time to hear Kamil, because he's an ambassador, let's say, of this architecture. Kamil, can you hear me?
Yes, I hear you. Do you hear me?
It seems something is wrong. Chat, let me see. You can hear. Thank you, Thomas. You can hear me, but Kamil, I cannot hear you. Can you hear Kamil? Or is it my problem? Let me check my sound here. Oh, that's my internet. It's okay.
Do you hear me?
TV, maybe. No. We can hear both. Thank you for that, but I cannot hear you, and that is a problem. For unmute your speaker. Okay, what is going on here? Kamil, can you talk now?
I'm talking now. Do you hear me?
Finally.
Yeah.
Guys, very sorry for that. I connected my laptop to a new screen here, to a TV, so I can see it in a bit better, let's say. And it seems it's feeding the sound to the TV, and the TV was off. So finally, I can hear you, and now I can see you, Kamil.
Great.
Very happy you are here today.
Me too. Thanks very much. Thanks for the invitation.
No problem. I think I will make another invitation for some time in, I don't know, fall or September, October. Let's see, for another talk, because I think that would be very interesting.
Yeah, me too.
Now that I'm sure I'm recording everything at least and it's working, I will stop sharing my screen, so you can start, and I will also let's see. I will close my camera, so everything will be okay. No problem with the internet. And Kamil, the stage is yours, I think. Thank you for being here.
Okay, so I will try to share my screen. Okay. Do you see my presentation?
Yep, I can see it. It's perfect. Guys, for questions, you can either use the chat, or I think, Kamil, we will have some time at the end, right? For any questions?
Yeah.
Super.
No problem with that.
Super. Okay. Thank you very much. I'm signing off for now.
Okay, thanks.
Bye.
Okay, thank you guys. I would like today to talk about modular monolith architecture, one to rule them all. So this is the table of contents. On the first section, I would like to general of monolith architecture. Second section will be about modularity. What does it mean? Modularity. What does it mean? Modularization. Next chapter, I would like to talk shortly about architectural drivers. What are architectural drivers, and when to, for example, use modular monolith architecture and when to use microservices architecture. And the last part of my presentation will be about design modular monolith, about example implementation of this architecture. So as George said, my name is Kamil Grzybek, and I am a software programmer, architect and team leader. I live in Warsaw in Poland. I have more than 12 years of commercial experience in .NET framework. I'm really passionate about software architecture, domain-driven design approach, clean code, clean architecture. So if you are interested in these topics, please follow me on the blog, Twitter, and LinkedIn, so we can talk and exchange opinions about that. This is about me. So let's move to the monolith. What does it mean, monolith? For these guys which you read book or see the movie Lord of the Rings, there is a quote that one to rule them all, one to find them all, one to bring them all, and in the darkness bind them. Yeah, so this is a very common quote from the Lord of the Rings story. So we can translate this to our monolith architecture. So what is monolith? It is a system to rule all modules. It is the system to find all modules. It's the system to bring all modules together. And in the one process, which is very important, one process bind them. So definition of monolith is system that has exactly one deployment unit. No less, no more. Yeah, it is very simple. So how the architecture of monolith looks like? It is very simple too. So as you see, there is a one execution environment, and we are deploying one execution unit to this execution environment, and that's all. I know it's not so fancy and great like in comparison to microservice architecture or cloud solution, when we have a lot of components, a lot of arrows, and the diagram looks great. Here it's very, very simple. Yeah, we have a deployment unit in one execution environment, and that's all. So from the marketing perspective, it's not so good. It doesn't look that costs a lot, but as we will see later, it has other advantages. But maybe you heard this quote from Phil Carlton. There are only two hard things in computer science: cache invalidation and naming things. So this is about modular too. So we have a lot of names for monolith, and for example, we have a monolith. Yeah, this is how I describe the main architecture. But we have modular monolith. We can have modulith. We can have distributed monolith. We can have even majestic monolith, and the big ball of mud. So a lot of names, very similar names. Only one of this name is not monolith, it's a distributed monolith, but still a lot of names for one architecture. And modular monolith is, I think, the most popular one, and modulith it's it is the same. This is the same name for modularized monolith. Same name of monolith is has a, I would say that it's very often combined with big ball of mud, that we have monolith, so we have big ball of mud. This is not true. Yeah, in my perspective, in my view, monolith is a single deployment unit. Yeah, and that's all. Let's move on to the modularity. I define what does it mean, the monolith. Let's define the second part of modular monolith definition, modularity. Well, what is the modularity? So by the English dictionary or American dictionary, modularity, modular, something which is modular, it's a separate parts when combined form a complete whole. Yeah, so we have separate things and we are combining them and we have something bigger, something the whole. Yeah. So the second definition is made from a set of separate parts that can be joined together to form a larger object. Yeah. And this is a modularity, the noun, and the verb, the modularization, is a process. It's a design of production of something in separate sections. So, for example, we have 4 modules, module A, module B, module C, and module D, and we want to have something modular. We need to take this part, execute process of the modularization, and the final result is something modular, which consists of the 4 modules. And this is from the definition overall. And the most popular example of modularity not connected with software engineering is a wardrobe. Yeah, because we have for example, this IKEA wardrobes, yeah, and they even say that the wardrobe is modular because we can take shelves, we can have different parts which have some interfaces combined together, these shelves, and we have a big wardrobe. And for example, these shelves are interchangeable, so we can change something, add something, remove something, and still this wardrobe is big and fulfill our requirements. So this is the example from the real life. But back to software engineering, what we defined what is the modularity, but what is the module? And again, we have different names for the modules, and sometimes we are using these names in different contexts. And for example, we have a module, we have a component, we have package. It's very popular in the Java world. We can have a service or even plugin. So as you see, there are a lot of names which in the first impression is that they are directed to the same thing, but in my view, the module is a logical unit. Yeah, so we're thinking about logical thing, not deployment unit, but logical unit. So monolith is about deployment. Yeah, it's a one deployment unit, and module is a logical unit. So as you can see, we can map that the relation could be different. We can have a lot of modules with one deployment unit. We can have a lot of deployment units with one logical unit. So what is the modular programming itself? Yeah, I want to talk now about the process of modularization in context of software engineering. So modular programming, for the definition from the Wikipedia, is a software design technique that emphasize separating the functionality of a program into the first important factor, independent modules. Second important thing is that they contain everything necessary to execute only one aspect of desired functionality. Okay, so modules are self-contained. They have everything to provide functionality. And the third important aspect is a module interface. Yeah, module needs to have an interface, which are either required by the module. So we have three the most important factors: independence, functionality, self-contained, and interface. And I would like to talk about these factors now. First, independence. What does it mean that our model is independent? How to measure it? Yes, because we should have some metrics to check if whether our model is independent or no, or maybe to some level. So the first factor, I think, is the most popular one, is a number of dependencies. How many dependencies our model has. So in this example, our module A has exactly 4 dependencies to module C, B, D, and E. Yeah, so we can measure it, 4 dependencies. This is a number. We can decrease the number of dependencies, for example, by introducing some mediator. Yeah, the mediator pattern. So this, for example, it could be it could be a broker. So for example, now we, instead of communicating to the module D and E directly, we are communicating to the mediator. Yeah, so now module A depends on exactly 3 dependencies. So on in this context, the module A is more independent than in the version on the left side. So this is the first factor. But is it enough to count dependencies of our model? It isn't, because there are other attributes. The second is how strong these dependencies are. Yeah, we can have weak dependency and strong dependencies. For example, when we are talking with other model very often, yeah, we have it's called chatty dependencies, chatty communication. This dependencies is very strong. Yeah, for example, we we cannot operate without this module B. So this is very strong dependency, and we can say that we are very coupled to this module B. On the other hand, we can have a weak dependency because we are communicating with this module from time to time, for example, one a week. So this is a weak dependency, and it doesn't pain us a lot. So this is the second factor of independence of our model. And the third one is frequency of dependency changes. So how often our dependencies change. And the example, when we have a module A and module A is dependent on module B, and the module B is very unstable. Unstable, it means change very often. So each change implies that we need to change itself. We need to change our implementation in the module A. But if the module is stable, the module B is stable, it means it changes very rare. So we need to change very rare as well. So this is the concept of stability. For example, in the .NET, we are very dependent on the string class. Yeah, we are using it in a lot of places and a lot of time, but still this class is very stable. Yeah, So it's impossible to change this class because it will break a lot of applications. So we can assume that this class is very stable, so we can depend on, and it's not so we can assume that this dependency will not break us, yeah, in the future. So to sum up, first factor, number of dependencies. Second factor, strength of dependencies, and third factor, frequency of dependency changes. And in context of independence, we need to always check all these three factors when you want to implement our functionality, our model. Yeah, so this is what we need to check. Second part of modular programming, the definition is about functionality. So the modular programming is about providing the implementation and fulfill some requirements. And according to the definition, we need to have everything in the model to fulfill some business requirement, some system requirement. Let's talk about this. We can think about modules in the technical way. Yeah, we can have GUI module, application logic module, data access module. So we have some horizontal modules. Yeah, and everything. The first impression, everything looks good. And for example, there is a change that we need to switch our data access model, and it's perfect. We are only changing data access model. For example, in the previous version, data access model was using ORM, and now we want to change for the Dapper, yeah, and we want to use raw SQL. So everything is okay. We are only changing the model of data access model, and GUI model, application logic model is untouched. But there is a one thing about this: how many times we need to change some technical part of our system, like data access model, like logging infrastructure. This is a very, very rare scenario. As you see, we often need to change our application because the business requirement was changed. So when the business requirement changed and we have technical models, we need to change each model separately. So in terms of modularity, definition of modularity, these models are very unstable, yeah, because one change propagates a lot of changes in all models. And this is when we want to change something or we need to add the new feature. So how to prevent that? We need to think about models in a vertical way, yeah. So I am sure that you are know this concept of vertical slice. So we have a slice which are from the top to the bottom, and the model is this kind of it contains a lot of slices. And for example, when we have something to change, like for example add some behavior or add some property, we can apply this change in this model. Okay, we can, in the model we can have some technical layers, horizontal layers is okay, but still the change is applied only in the one model. Other models are untouched. And the third most important attribute about modular programming is the interface, the contract. Let's see what is happening when we don't have the contract, the interface of our module. So our module A directly invokes some internal classes, some internal components of module B. So if we are developing module B, we don't know if, for example, we are changing some class, we are breaking module A. Yeah, we don't know that because we can change we can track this. So we don't have this kind of encapsulation, and it's very it could be very often to break module A. How to prevent that? We need to provide some kind of interface and hide everything behind this interface. So for example, we can create the facade. It will be an API of our module B, and module A can only invoke some behavior of module B through this facade. Yeah, we have a very strict contract, the interface, and what is the behind the facade? It's a implementation details. Until we are not changing the facade, we can refactor module B, do everything we would like to, until the facade is not, it doesn't have any breaking change. So this kind of design involves the contract, the interface, and the encapsulation of the module. Yeah. What is important that in the case of event-driven architecture, because not always we have synchronous communication, we can have asynchronous communication. The event which are published and which is canceled is the part of the contract. Yeah, for example, if you have 3 properties in the event and we want to change some property, it's a breaking change. So event is the part of our contract. So this is why we need to have a very slim events opposing to the fat events. It's called fat event. So only publish information we need to the other modules needs to get. Yeah, so because if we will add a lot of information in the events, so the contract is bigger, and every change will we can provide to the breaking our subscribers. So to sum up this part, modularity is about independence of our models. Modularity is business driven, and we need to provide the interface and encapsulate our internal implementation details in our models. Okay, let's move on. Let's move on to the architectural drivers. Sometimes we are in the role of architect, and we need to choose which software architecture we need to use in our project. And a lot of projects start from the big ball of math. Big ball of math is an anti-pattern. When we have a lot of things combined together, everything talk with other thing, and everything is connected with other thing. So it's very unmaintainable. It is very hard to change. It is very hard to reason about this kind of system. And in the last, I would say, 8 years, it was a switch that we need to do something with this big ball of math, and we need to separate this big ball of math to the microservices. So we need to chunk this big ball of math and distribute it. So we have a distributed system and everything will work. But what was happened is that it is very hard to do microservice architecture because we need to we need to have modules, yeah, in our system, and only by separating to the separate processes our modules, it's called modules, it doesn't solve our problems, because we need to think about modules boundaries, yeah. So in terms of modularity, we can go to the modular monolith or microservices, but if we will do microservices wrong, we will left with the distributed monolith. So this is the nightmare, the worst architecture of all of them. So we have everything which is talked with each other and in the separate process. So everything is collapse. So the answer, the question is, should we choose modular monolith architecture or microservices in that good way designed architecture? And what to choose? The answer is architectural drivers. What are the architectural drivers? First of all, architectural drivers are concepts which shape our architecture. So we have 4 categories of architectural drivers. First category is the most basic one, functional requirements. What problems does system solve? Yeah, which requirements we need to implement, which we need to fulfill. So what we should do? This is the most important, I would say, part. So even the quality of our system is great, but it doesn't fulfill our requirements, it's useless. On the other hand, we have a quality attributes, architectural drivers quality attributes, and this is focusing on not what, but how it's implemented. What is the quality of our solution? Set of attributes that determine quality of our architecture. So what we need to do is to implement some functionalities and to be sure that they are very good quality. What does it mean, good quality? We can talk later. But it's not everything. We are constrained, and we have technical constraints, which, for example, this is a technology standards, tools limitations, team experience. For example, we want to go to the microservices architecture, but we don't have experience, yeah, or we don't have tools. Or for example, in our company, the technology standard is to use only SQL server database server, and we can't use, for example, NoSQL database, and so on and so on. So we have on the one side is technical constraints, and second constraints are the business driven. For example, we have a hard deadline and we are not able to provide, I don't know, microservices architecture in 1 week, yeah, but we need to do something. Or we have a budget, limited budget, so we can't buy something, and so on and so on. So we have two constraints, technical and business, and we need to implement functional requirements with the quality attributes. And I would like to focus on quality attributes because I wanted to compare some attributes according to microservices and modular monolith architecture, because functional requirements and technical constraints, business constraints are very context specific. Yeah, in the each product is different and has different constraints and functional requirements, but quality attributes are often common. So the first one of quality attribute, I would like to talk about the complexity of the solution. And in context of the complexity of the solution, when we have one process, we have a monolith, so everything is simple. Yeah, we have a simple method call, which is the module is always available. We have address of this module because it's the in the memory, in the process memory, and this communication is always secured. So I would say that the complexity is very, very small. On the other hand, we have a microservices architecture, which is distributed computing architecture. So we have different processes, and things are complicated because we need to have an address of our module. We don't be 100% sure is it available or no. We need to communicate, use some protocol of communication to communicate with this module. And we need to provide the security, yeah, for example, authentication or HTTPS mechanism, yeah, to encrypt our messages. So things are complicated. Of course, these issues, these problems which I described are resolved by some tooling in the microservices ecosystem and by patterns. And this is, for example, the print screen of Chris Richardson, which is a microservices evangelist, I would say. Yeah, and it represents some patterns to solve this issue. But still, every tool in our solution adds complexity to overall solution. So every pattern do the same. So we need to be very careful by applying this solutions. Okay, next. Next architectural driver will be a productivity. So in case of monolith, the productivity is very simple. We are pulling our code base, executing F5, and it works. Yeah, each module is running in the same execution environment. Everything works great. In case of microservices, it's more complicated because, for example, we can have multiple code bases. We can have mono repository, or we can separate repositories. So this is the first thing, which is more complicated. And second thing is about execution environment. We can have multiple execution environments. So we need to install some things to run our application, or of course we can use Docker or Kubernetes to solve these issues, but still it is a more complex solution. But we need to look at this architectural drivers from different perspective, because, for example, if we have a lot of people in the project and the code base is very large, sometimes microservices will provide more productivity because by splitting the code base, it will be faster to implement some stuff. So we need to look at this architectural drivers in, I would say in different angles. Yeah. Deployability. So deployability in context of complexity in the modular monolith, it's very simple. We are deploying everything and it works. But in the microservices, we can deploy separate module, only separate module. So the speed, the velocity of changes is better. So in that case, the same thing which I talk about productivity. We need to check which in our project, in our context, what is the better. If we need to, for example, deploy separate module, this is the driver to move toward microservice architecture. If we don't need this kind of behavior, maybe modular monolith will be enough. Scalability. Okay, there's a myth. There's a myth in the internet that we can't scale monolith monolith architecture, and it's not the case because we can scale monolith, but we need to scale whole monolith. So the resource utilization is not so well, it's not so efficient. In the microservices architecture, we can scale. Of course, I'm talking about horizontal scaling. We can scale only one module, for example, the module B 2 times. So we are using less power, so the resource utilization is more efficient. Yeah, and this is one of the factors which is very important in the cloud solutions, because every computing power in the cloud costs adds to our invoice. So this is a very important thing to consider when you want to host your application in the cloud. But on the premise, sometimes it doesn't matter if you want to scale free monoliths instance. Okay, it's okay. Maybe it's a better solution, or maybe microservices, because we want to utilize our resource better way. Next architectural driver is a failure impact, which is a very important one. In monolith, from the definition, everything works in the same process. So in case when the one module crashes, everything crashes, yeah? Everything is stopped. So if we have, for example, one critical module, we should operate very, very stable. And we have some unstable module, and it's not a critical, like for example, some reporting or creating PDF. And this creating of PDF will stop our monolith. It is not a good solution. In the microservices, we can have separate processes, one for the critical module, one for the unstable module. And when the unstable module is stopped, the critical module still works. So this is a better solution, which can mitigate the risk of a critical module when it's stopping. And I had this issue in my experience when we have some not critical module which was responsible for synchronization to the Microsoft Exchange calendar. And it was the case that from time to time, this client, which was provided by the Microsoft client, which was responsible for the API for the using the Exchange, from time to time, it took 100% of the CPU, and whole process crashed. So we needed to separate this synchronization module to separate process, and thanks to that, our critical other modules run correctly, and this unstable module from time to time would crash, and we can investigate it later. So this is the next thing to consider. And the heterogeneous technology. In the monolith, you don't need to have one language, because there is a common runtime language. Yeah, so for example, you can use C#, F#, Visual Basic, but still it's a common runtime. So our options are limited. In the Java world, you can have Java, Scala, Groovy, etc., etc. But in the microservices application, you can have totally different execution environments. So the question is, do you need that? If you need that, this is the driver which will toward you the microservices. If you don't need this kind of heterogeneous technology, you can stay on the monolith architecture. And there are a lot of much more architectural drivers in context of software architecture. So you can enter in the Google architectural drivers and you will read a lot of stuff about that. And so this is very, very useful, and I recommend that. And let's move on to the design. To the design of modular monolith. And I would like to talk about architecture enforcement, because everybody wants to have great architecture, very maintainable, very scalable, etc., etc. But at the beginning, everything works great, but when the time passes, it has happened that we are seeing this is a big ball of mud. And why is that? Because we didn't enforce our architecture. Yeah, we decided that we will do something, but we are not enforcing that. And enforcement is a very important aspect of software engineering. So we have 3 levels of enforcing our architecture: compile time, automated tests, and code review. And let's move on to the compile time. The first most fundamental rule is private by default. Yeah, this is opposite than everything, maybe not everything, but most what I see in the GitHub repositories or in the even the commercial solutions, that everything is public. Yeah, everything is public. Maybe some methods are private, but still I can't use everything from every model, every class, everything is public. Even the IDE, when I create the class, it's public. And this is a nightmare. So we need to change our mindset and start with the private by default. Everything what I creating should be private. And after that, if I need this member, class, or module in the scope of the module, I can open this member to the internal, yeah, in the internal in the .NET, for example, in the I think in the Java it's a package scope, but still this is the second level of visibility of our member. So we need to provide this encapsulation. So when something is not private, it should be internal. And the last resort is the public, yeah, and only the public things which are in the model should be very, very the smallest number of things should be public. Yeah, only our contract. Yeah, only things we need to expose by our model should be public. So this is the first the first rule, and our compiler is our best friend, yeah, as programmers. So we should treat our friend carefully and use them as much as possible. Second level of architecture enforcement is unit testing of our architecture, yeah, automating it, because not everything could be checked by the compiler itself, but it doesn't mean we need to put everything in the code review. We can automate, and we should automate as much as possible. And we can do it in the two ways. First of all, we can use, for example, some static analysis tool like ndepend, which has a defined set of rules and we need to enforce. And the second approach is to implement some unit tests for our architecture. And this is very, because unit tests should be very fast. So this is fast too. And this is an example from the Java library, but still we have in the .NET something similar. So we are implementing our unit test that, for example, this class, which is assigned the package this, shouldn't or should depend on class this. For example, classes from the domain layer shouldn't depend on infrastructure layer, and that's it. And very few tests, yeah, very simple tests, and you can enforce in the automatic way a lot of things, yeah. So you don't need to check in the code review. So code review is quicker. And third level, it's a code review, because sometimes the rule, you cannot check everything using compiler and automated tests. Sometimes the real person needs to review our code. But sometimes it's code reviews, you know, sometimes it's very you need to a lot of time to do that. It's very time consuming. So to provide some I would say help to this process, we can provide architecture decision records, ADR. And what does it mean? Architecture decision record is a record of, it's a document. It's a very simple document that captures an important architectural decision made along with its context and consequences. So, for example, we are this is an example of template for this architectural decision record, and we are writing the title, the status of this decision, the context, because each decision is made in context, and this is very important, and decision and consequences of the decision. For example, we can check. For example, we need to decide if we want to use, for example, clean architecture, or we want to use two-layer architecture. Yeah, so we have title. We chosen clean architecture. Status is accepted. Context is that we need to change. We need to. We have a start of the project, and we have a complex domain, and we need to decide the architecture. Decision is yes, we made the decision that we are using clean architecture, and consequences will be that the domain will be isolated from the infrastructural level, but this adds complexity because we have 3 layers and it's more complicated than 2 layers, yeah, for example. So this is this example of architecture decision record, and in the code review we can point to that architecture decision record, because it could be kept in the GitHub repository, that saying, okay, we chosen that we using clean architecture, but here you are this code it breaks this rule because you are executing some database stuff from the domain model, yeah, and you are pointing to this, and you don't need to you don't need to write everything about this, yeah, so you can only link to this record. Okay, so this is about enforcement and about integration of our models. The first choice, if we want to have to support module autonomy, is to provide event-driven communication, asynchronous communication, because it provides it provides less coupling than synchronous communication. Second choice should be a direct call, yeah, because we have asynchronous communication. Second choice should be the direct call, but as we have seen earlier, it should be provided by the facade or the AP. Module 2 should provide the facade. Okay, and you can invoke this kind of behavior only by this facade. And only the last resort, the first choice should be shared data, because when we have shared data, shared database, we don't have this kind of encapsulation. We have in the database itself, we have different concepts modeled in the different ways. So there are a lot of things which can broke our model. So this is the third choice. If we really need to do it, make it by sharing the data, the database, but let's think about this if we can do event-driven architecture on synchronous calls. And the last thing I would like to present the example architecture, how it should look like. So we have the API of our of our application, and we can use, for example, CQRS, command query responsible segregation, to our model. So we are sending to our modules only commands and queries, and our modules are communicating through some events bus. It could be event bus in the memory, or it could be event bus like a RabbitMQ. So they are communicating by the events, and each module has own data. Yeah, there is no data sharing between the modules. So it is possible from one module to second module that invoke some direct call, like module 2 through the gateway invokes module 3 through the facade. But as you see, there is a clear, explicit interface that we are providing here. So this is a good way to do that. And not only API is our client of our models, because, for example, we can have integration tests which are using the same API of modules, yeah, and it works the same. So we have API client, we have integration test client, and for example, we have a domain model in one module, module 1, and we can write the unit tests for this domain model. Of course, we need to expose this domain model public, yeah, but this is a trade-off, okay? So this domain model is complex enough, so we need to expose it and expose some public methods to unit tests. But okay, because we can't hide everything in our model, but this is a trade-off, and we are agree that it will be okay. And in that design, we can decide which model should have which architecture, the internal architecture, because sometimes the model can have could be a very complex domain model. The business requirements are very complex, so we can, for example, have a clean architecture, onion architecture, ports and adapter, everything is the same, but we have this separation, yeah. But in the other model, we can have 2 layers, for example, because it's very enough. It's very simple, and even we can have 1 layer which is very similar, which is very easy. For example, it is some kind of proxy which integrates with the external API with the, for example, the payment. So this is there are minimum logic in this model. So we need to provide clean architecture and 3-4 layers, yeah, because it's over designed. So summary. Let's move to the summary of my presentation. First of all, monolith. It's a one deployment unit. It doesn't mean it's a big ball of math. It's just one deployment unit. Modularity. We talked about independence. Modules should be business driven, and they should provide, then should have a contract and should be they should be encapsulated. What to choose? The answer is architectural drivers. We need to consider each architectural driver in our context and decide what is the better. So there is no silver bullet. There is no answer. Always the answer is in particular context. Yeah, we have a problem, we have a context, and in that context we need to answer about what need to choose. And I presented some architectural design, example design. Okay, this is only one of the example. You can create something similar or something different, but the principle should be, in my opinion, the same, like encapsulation, modularity, yeah, and the enforcement. After designing, we should enforce that our team don't break the rules, and we should use compiler for that, automating stuff, automating tests, and for example, code reviews and architectural decision records for the to help our team enforce our architecture. So that's all from me. Call to action. If you would like to see some implementation of modular monolith, I encourage you to visit my GitHub repository, github.com Grzybek modular monolith with DDD, and I encourage you to see my website or Twitter, which I talk about modular monolith and domain-driven design and software architecture in general. Thanks.
Oh, thank you, Kamil. That was super interesting and very enlightening, to be honest. And fun fact was that every once in a while I had a question, and then the next slide or another one, you were answering it. So it was a very good presentation, I would say. Nevertheless, we have some questions. I would suggest, if you guys agree, instead of me just transferring the questions to Kamil, we could very well, for example, Ahmed Atia, I hope I'm pronouncing your name correctly. If you want, you can open your microphone and ask the question directly to Kamil, if that is okay.
Yeah, sure. You hear me?
Super.
Yeah, I hear you.
We can hear you.
Yeah. So my question about the vertical slices architecture, I hear a lot of comments and suggestion about it. So I need to see
something is wrong with your sound, I think.
Yeah, it was very loud.
Oh, really? Sorry for that.
Oh, can you repeat?
Yeah, I'm talking about vertical slice.
Vertical slice, okay.
So have you used it ever in production? Any experience with how the project structure would look like? Because I'm a bit confused about using it in production for real.
You mean vertical slices, yeah?
Yep.
Okay, so your question is whether I use it in the production. Vertical slice. Yeah, I'm using it, and I will say that this is my default option, because in my opinion, we should focus on I'm referring to the feature folders. Yeah, for example, you don't have, for example, in case of implementation, you don't have folders for controllers, application services, and domain model. You have a feature folder. For example, the slice could be a add order or cancel order, and in that case, you can have, in the cancel order, you can have a add order command, add order handler. You can have even the order entity domain itself. So everything which is associated with this use case or user story is in the same folder. So it's the slice, and it has a high cohesion. Yeah, it has high cohesion because it changes when this requirement changes.
I see that, but the problem here is where the UI would be, because I'm always confused how the project structure would look like in that case, because here I will have the UI, the application user data access in one single folder. So where would my UI end in that case?
But you mean about
so let me ask it in another way. If I end up with one folder for everything, including the UI, the application, the business domains, the entities, and the data access, how that folder would look like? Or I will end up with different projects, which is the second question posted here. So each project will represent each single function or purpose, like one for UI, which is the web as usual, or another one for application, another one for infrastructure that includes the data access. So in that case, I will have vertical slices across multiple projects or multiple layers.
Yeah. Okay, I understand the question. Yes, you can have multiple projects for different technical stuff like application, like domain model and data access. Yes, it could be in different projects, but still this project should be combined in the one module. I will say that you don't have okay, this is a Jimmy Bogart's solution that you have everything in, for example, one folder and in one project. Yeah, because I am not sure if this is the right solution, because for example, if I have a domain model which is complicated, I would rather to separate them in the separate project. So I have and I can use, for example, encapsulation and use internal keywords and that kind of stuff. So I would say it depends of the slice, of complexity of the slice. If it's very simple, I will create every class in the same project. Yeah, it could be a one technical layer, and you can, for example, use the namespaces. But if the domain is complicated, I would say that from my experience, the better way to do that is to separate, for example, even the domain model itself. Yeah, so you can, for example, unit test when you are, because you are unit testing domain model. So it is a client of domain model. So you don't need to reference GUI stuff and other things. You are referencing from the unit test project only the domain model project, and you are executing some logic.
Okay.
Yeah, sure.
Just one note, I will add something to this question. Thomas has very good questions, two of them, but Samir asked something in relation to vertical slices. So I think that's maybe it's better if we add that now. He says that he would be interested in the relation of vertical slices to the team's organization. If you can understand the question, I assume how you organize your teams based on these vertical slices. If Samir, I'm not transferring correct your questions, please feel free.
No, that's exactly that's exactly the question. So how would you organize, considering the environment where you have multiple projects and multiple teams? How would this architecture fit into this organization? So how big is actually Slice? Is it one team that takes care only about one slice that's domain oriented? And what happens when there is not enough feed to this team, so to say? Because in project development, you don't have always same intensity of requests to certain slides. Some slides are more static and the others are more dynamic. They change more frequently.
Okay, so I understand slice as one use case, why one user story. So the module contains a lot of slices in the boundary of this module, yeah? So in my opinion, and this is the advice for the microservice architecture, so one team should be responsible for one service or one the module if the mapping is one-to-one. So slice is only the one use case, yeah. So it's I would say that it is small thing. So the team organization based on vertical slides is, I would say, is not good. But about the module, like for example, shipping or payments or something like this, will be better.
Maybe if I may just another question. So would you consider vertical slice here equal to module in this context? So the question is more, do you consider a module or vertical slice here as a self-contained system, something that a team builds, owns, deploys? It can be independently deployed and released also independent from other vertical slices.
Yes, module is independent, is self-contained, but it's in the monolith architecture. It is not self-deployed, yeah, because from the definition everything is deployed at once. So everything what you said, I agree, except the deployability attribute, yeah, because if you want to have a deployment in the separate, if you want to separate the deployment, you need to create the separate process, like separate service.
Okay, thanks.
Okay. Are we okay with the vertical slices questions? Because if yes, that would be time for some very interesting questions from Thomas.
Yeah, but I mean, it's still considering vertical slices. So I have one question. The what we see in the current slide is a n-tier architecture, and the next step after this is kind of an onion-shaped architecture. But even in an onion-shaped architecture, and I think you have some slides about this, if you now go for vertical slices, that means you have slices that go from outside inwards, right?
Okay.
You have different modules. They will still rely on common domain logic. They will probably use the same UI framework and stuff like this. So how do you get this into an onion-shaped architecture?
Okay, so you mean about this onion architecture, yeah? Thomas?
Yep, that's what I mean. I mean the slide afterwards, yeah.
Yeah. So the assumption is that modules don't share anything. Yeah. So as I said in the presentation, we can have different shapes of architecture in modules. So you can have onion architecture in module A, but 2 layers in module B, and we are not sharing anything. Of course, for example, here we have the API. So okay, you can have some shared classes like building blocks. For example, I can say that if you have domain model in the module 1 and module 2, so we can have a building block shared library which have interface iDomain event or I something, yeah, and they can share this interface, but it doesn't mean they share some logic. They don't share anything. They share some common classes like utility, but the number of sharing components should be minimal. So the goal is that if we want in the future to separate some module into separate process to, for example, create a microservice architecture, it is very, very easy to do that, because you are taking whole projects, like, for example, you have here 3 or 4 .NET projects, and you are moving it from this solution, and you are moving into the separate solution, and you only need to host and initialize this module, and everything works as it worked in the monolith. So this is, I see that modules as separate at mini applications, in bigger applications. Yeah. Did I answer your question or no?
Yes, thank you.
Okay.
The other question was more from a very technical point of view. If we now look at the .NET world, let's assume you already have a architecture which is not modularized, but it's either n-tier or onion-shaped, and you now want to split it. What's technically, in your experience, the best way to do it? Is it sufficient to split it into different projects which represent a module, or is it even worth deploying them independently as NuGet packages, or would you even go for completely separate repositories?
I don't have experience with separate repositories with in the modular architecture solution. But if you want to start the process, in my opinion, you should prepare to this. You should be prepared to this by refactoring. Yeah, because if you have everything in one module, it is a very great chance that this is some kind of big ball of mud. Yeah, in some way. So you need to provide the encapsulation in that module. Yeah, try, for example, the rule of scout. Every comment, for example, is a change of method, encapsulate something. Yeah, provide API, provide a gateway, and try this. This is the first step. A second step will be a separating, for example, to the second project. Yeah, but the hard part is a boundary of the module. Yeah, and this is the hardest part in the microservices as well, because there is no algorithm for this. There are a lot of heuristics. For example, in the strategic domain-driven design, there are a lot of heuristics how to define the boundaries between the modules, like bounded context. So if you want to split it, in my opinion, for example, the first thing what I will do is the event storming session. So in the event storming session, you are seeing a lot of events and what is happening in your project, and the result of event storming session could be finding the bounded context. And if you have a bounded context in your application, you can go to the implementation and try to separate the whole solution to split solution to the, for example, 2 modules based on the bounded context which you explored and identified. But I would say it's not a big bang rewrite. It is very it's not a good solution to stop everything and try to rewrite in the modular way. I think it's an incremental process, so you need to step by step think about boundaries, think about overall solution, and try to split it in the incremental way.
Okay, thanks.
Okay, nice. Anyone else? Any other questions? Nope, no one.
Yes, sorry, can you hear me? So I would
Yes,
have.
yes, Sebastian.
Yes. Hey,
Yes.
Sebastian.
Hello. So thanks for the talk, and I know your GitHub repo. So it's, I would say it's already really big. So would you start from that GitHub repo, or would you start with something smaller and then build it into that direction when you start a new project?
Mm-hmm. Of course, it depends, but I will say if it is a simple application, and it will be in the future, I will say that it's not necessary to create this kind of architecture. But from my experience, project starts with a simple application, and in the future it evolves to more complicated one. So I like good structure and software architecture from the beginning. So in my opinion, even in the simple application, there are always two modules, maybe not always, but but very often. Like, for example, we have some business functionality and user access. Yeah, for example, in most of the application we have authorization and authentication. Yeah, and this part you can implement in the separate module. So you have user access module, which provides authentication and authorization to our application, and you have second module which provides functionalities. Yeah, so this is it could be from the beginning, and if the project grows, this business module can grow, and you need to decide, okay, this is the time we need to split it. Yeah, so move some functionalities to the separate module.
Okay, thank you.
Thanks.
Cool. Anyone else? I can't see you, so it's always this awkward moment at the end that you cannot understand. If there are any more questions, I will just add one thing, and maybe there will be some questions after it. I don't know. You have some time to think. I think that yeah, if you anyway have your loosely coupled modules, these let's say well encapsulated components, you are anyway on a path towards an agile architecture, and that means that you are very close to a microservice architecture. Now, if you will go to a microservice or not, I don't know. Kamil, of course, answered this question, how you will choose that. Maybe this will be the first step and you will finally go to microservices, or your software will spend its lifetime using this approach. Nevertheless, since I think, in my opinion at least, since microservices is a very expensive approach, you can easily end up with tangled services with these spaghetti calls that resembles, I think, Kamil, you called it distributed monolith or something, this pattern. Yeah. So I think it could be anyway a good approach to take it slowly. Maybe start here, and then you will end up very easily to a microservices solution, or anyway, the parts of your project that needs to go to a microservice solution could very easily do it. At least this is how I see it. In any case, it was extremely interesting for me. So thank you very much, Kamil.
Yeah, George, exactly, I agree with you. And even Martin Fowler wrote the article about this, and it's called Monolith First. Yeah, so this is the approach. Yeah, so
exactly.
Always start with the monolith, and if you really need to, separate some modules to the microservices. Yeah, and not the opposite. We are creating microservices, and we need to combine together because it's very expensive. So totally agree with your approach. And of course, there is no silver bullet, and sometimes there is a specific project that you are 100% that it needs to be a microservices architecture, because you know that there will be a lot of people and the scale is enormous. So it could be like that, but in general, the monolith is the default choice, in my opinion.
Yeah.
This is my experience.
Yeah. Nice. Very interesting. And I will correct me. Now it's the awkward moment. I don't know, should I end the meeting?
Yeah.
Guys, if you don't share, if anyone has something, just turn on your microphone and talk, or I think I can stop the meetup right now, right? Yep.
Maybe
Okay.
just a comment from my side. Thank you very much for sharing your experiences and for this talk. It was very useful. Yes.
Oh, thanks a lot for the feedback. Yeah, I appreciate that.
Thank you, Samir. And yeah,
Okay,
I will upload everything to YouTube. You still have some time if you want to hide your name or anything, so feel free.
I wanted to say, if you have any questions in the future, please contact me by my blog or by Twitter or LinkedIn, so we can talk. And I like to discuss, and I like to discuss with people which has different opinions. So please, you are welcome. Let me know, and we can talk about this.
Cool. Nice. Nice. So thank you, guys. Have a nice rest of your after. There are two chats which there where we can find the recording. Okay. So I will upload it to YouTube probably later tonight, and then I will add the link under the meetup in this discussion comments how in meetup.com, and you can find it there. Or you can go directly to our meetup, to our YouTube channel of Munich NET Meetup. You can find it in meetup.com. So yeah, both ways.
Great.
So thank you all. Thank you for your time. Most of all, thank you, Kamil, for your enlightenment. It was really, really interesting. Thank you very much.
Thank you very much. Thank you.
And I hope we can talk again sometime in the near future. I don't know, fall or something. We can repeat something interesting.
Yeah, we can talk. Yeah, it was a pleasure.
Okay, thank you. Thank you. Ciao, guys.
Thank you very
Bye.
much. Bye.